Hey guys! Welcome back to the channel. Today we're talking about one of the most important electronic components that you'll see almost everywhere. The capacitor. Think of a capacitor like a small rechargeable battery. It stores electrical energy and then releases it when needed. But unlike a battery, it can charge and discharge very quickly. Now let's check out the awesome benefits we can get from using capacitors. Capacitors can smooth out a power supply, and here's how. When you take AC from a transformer and pass it through a rectifier, you don't get clean DC. Instead, you get a wavy output full of ripples. The solution to this is to use a capacitor to smooth the DC voltage. The capacitor stores charge when the voltage increases and releases charge when the voltage decreases. This way the ripples get filled in and the output becomes much smoother and more stable. For example, think of a capacitor as a water tank and voltage as a tap. The tank stores water when the tap is flowing fast. When the tap slows down, the tank releases water to keep the flow steady. That's exactly what a capacitor does. It fills the gaps in voltage and keeps the power smooth. Capacitors can be used for signal filtering, and here's how. A capacitor blocks DC signals, but lets AC signals pass through. When combined with resistors, it can filter out specific frequencies, like cutting out noise or shaping sound in audio systems. That's why you'll find capacitors in radios, amplifiers, and communication circuits. They let the useful signals through while blocking the unwanted ones. Capacitors are the gatekeepers of signals. Capacitors can also be used in timing circuits. They charge and discharge at a predictable rate, and when combined with a resistor, you can control how long that process takes. This is called the RC time constant, and it's the basic principle behind timing circuits like delays, LED blinkers, and 555 timer circuits. Simple but powerful. Now let's see how to identify a capacitor. Capacitors come in different types. Let's take a look at them. Electrolytic capacitors usually look like small cylinders. Most are black, blue, or brown with markings printed on the body. Electrolytic capacitors have polarity, meaning they have a positive and negative side. The negative side is marked with a stripe or minus symbol running down the body. The positive lead is usually longer while the negative lead is shorter. Always connect them the right way in a circuit. If reversed, they can get damaged or even explode. On the capacitor body you'll see numbers like 100 microfarads, 25 volt. The first part tells you the capacitance value. The second part tells you the maximum voltage it can handle. Example. A capacitor marked 470 microfarads 16 volt means it can store 470 microfarads and handle up to 16 volts. Some capacitors also have a temperature rating like 85 degrees Celsius or 105 degrees Celsius. This shows how much heat it can safely handle. A ceramic capacitor is one of the most common capacitors you'll see in electronics. They're small, lightweight, and usually non-polarized, which means you can connect them either way in a circuit. Ceramic capacitors are usually small and disc-shaped. Often found in colors like orange, brown, or blue. But in modern electronics you'll mostly see them as tiny SMD components. You'll see numbers like 104, 473, 221 printed on them. These are codes for the capacitance value. Ceramic capacitors don't use color bands like resistors. Instead, they use number codes printed on them. The first two digits are the main value. The third digit is multiplier. Number of zeros to add. The unit is in picofarads. You can find the value of ceramic capacitors by using a simple chart. Let's check out how to read it and figure out the value step by step. For example, let's look at the ceramic capacitor. The first two digits is 47. The third digit is 3. The value is 47,000 picofarads. Film capacitors are a type of capacitor that use a thin plastic film as the dielectric. They're popular because they're stable, reliable, and have low loss. Usually rectangular or box-shaped. Often come in yellow, green, blue, or red plastic casings. Always discharge the capacitor before testing. Short its leads with a resistor, not directly with a wire, to avoid spark. Set the multimeter to resistance mode. Connect probes to capacitor leads. For electrolytic caps, red positive, black negative. A good capacitor will first show a low resistance, then slowly rise towards infinity as it charges up. A shorted capacitor will always show 0 ohm or very low resistance, with no change. An open capacitor will instantly show infinite resistance and stay there. Capacitance mode. Set the multimeter to capacitance. Connect probes to the capacitor leads. Reading should be close to the capacitor's rated value. Printed on body. If way too low, capacitor degraded. If it shows 0 or doesn't settle, bad capacitor. If you learned something new, make sure to like and subscribe. And hit that bell so you never miss an update. Got questions? Drop them in the comments. See you in the next video. Take care.